Today's lesson is 7-8, and this is our day 1. We're going to multiply binomials algebraically and using manipulatives. There are 6 examples. Go ahead and write down number 1, or 1a. It says parentheses 3 plus 4 parentheses, parentheses 2 plus 7, close your parentheses. It says use order of operations to solve this problem. So with order of operations, it says to do parentheses first, so that's what we're going to do. 3 plus 4 is 7, and 2 plus 7 is 9, and then we're going to multiply 7 and 9 and get 63. Go ahead and write down 1b. It's exactly the same problem. It says 3 plus 4 in one set of parentheses, and then 2 plus 7 in the second set of parentheses. Now we're going to show a little bit of a different way to work this. We're going to use the distributive property to solve this problem, and we'll notice that we get the same answer. So to use the distributive property, we're going to take the 3 and multiply it by everything in the second set of parentheses. So we're going to say 3 times 2, and then we're going to say 3 times 7. So you're going to take the first number here and multiply it by both things in the parentheses in the second set. Then you're going to take the second number, the 4, and multiply it by everything in the second set of parentheses. So we're going to say 4 times 2 and 4 times 7. So right now we have 3 times 2 plus 3 times 7 plus 4 times 2 plus 4 times 7. We're going to multiply all those together. 3 times 2 is 6, 3 times 7 is 21, 4 times 2 is 8, and 4 times 7 is 28. So that's what we've got now is 6 plus 21 plus 8 plus 28. We're going to multiply all those together.
Add all those together.
Add all those together, and we're going to get 63. Notice that whether we use order of operations or if we use the distributive property, we came up with the exact same answer of 63.
And the whole reason that we have to use this in the following examples is because we have variables. And if we don't have variables, then yeah, we could just add and multiply. But you're going to have variables in all of these problems, so we have to know the proper way to work them when we don't know what the value is.
So it says, why would we use the distributive property to multiply binomials instead of using order of operations? So just like Ms. Fielden was saying, you would use the distributive property to multiply binomials instead of using order of operations if you were given variables instead of numbers. So if I turn that 3 and the 2 into an x, we could no longer use the distributive, or we could no longer use order of operations, and we would have to use this distributive property. You do not have to write down the words in blue, just make sure that you have the work here and the work here before you move on.
All right. You're going to need graph paper for this lesson, and I want you to write across the top of your graph paper notes 7-8. Notes 7-8. And then I'm going to tell you exactly how to set up your graph paper. But go ahead and write this problem down on your paper. It's number 2, so your graph paper is going to start at number 2, and just write in parentheses x plus 5, close parentheses, open parentheses, x plus 3, close parentheses. And now I'm going to switch over and show you what your paper should look like. Okay, I'm sorry, I messed that up. We're going to show you what this looks like with the distributive property first, and then we're going to show you what it looks like using Algebra Tiles on your graph paper. So you are still on your notebook paper here, and I'm so sorry for that. But get your notebook paper back out, which should also have notes 7-8 written across the top of it, and go ahead and get this down.
So this is parentheses x plus 5 parentheses, then parentheses x plus 3. So we're going to distribute. So we're going to take that x and multiply it by everything in the second set of parentheses. So we're going to say x times x, and then to that we're going to add x times 3.
And you should be drawing these arrows on your paper.
Then we're going to take the 5 and multiply it by everything in the second set. So we're going to say 5 times x is 5x, and then we're going to say 5 times 3, so plus 5 times 3. So this first step, you should have x times x plus x times 3 plus 5 times x plus 5 times 3. We're going to go through and multiply, so we're going to say x times x is x squared, and we're showing you that that is actually using the exponent property number 4 that says if we have the same base, we add the exponents here, so we have an exponent of 1 in both places, so that turns into 1 plus 1, which is x squared, or x to the second power. Then x times 3 is 3x. 5 times x is 5x, and 5 times 3 is 15. So we have x squared plus 3x plus 5x plus 15. Then we're going to combine the like terms, and if you do this correctly, most of the time you'll be able to put these two middle terms together. And we can put those together because they are alike. They both have an x without any exponent to them. So we're going to say 3 plus 5 is 8. So our final answer here is x squared plus 8x plus 15. So we just took the two binomials of x plus 5 and the binomial of x plus 3, and we multiplied those two binomials together and got x squared plus 8x plus 15. Again, you don't have to write any of the words in blue. Please just make sure you have all of the words or all of the work written down, this work right here, before you move on. And Ms. Hilden's going to now show you how to work this exact same problem but using your algebra tiles.
So we are going to graph paper officially this time. Okay, so here's your graph paper, and it's set up like I asked you to go ahead and set it up with your notes 7-8 across the top, and then your problem is written down, and again, like Ms. Singh said, it's the exact same problem. So for this lesson, I'm going to use a little ruler. You don't have to, but it's just a whole lot easier, and it's going to look a whole lot neater if you go ahead and set these up with a ruler. You can also just use a flat edge like of your binder or of a notebook of some sort. You know that in the past when we've done algebra tile problems, we've asked you to set up a T-bar. This one's going to be a little bit different. With these problems, we're going to ask you to set up your bars like this. So you're going to have them cross or intersect over here in the corner. And what we're going to do is we're going to set up one side of our problem down this side and one side of our problem down this side. So on this side, I'm going to put my x plus 5. And I'm going to show that. That's my x plus 5 right here. It's going down here. I'm going to show that by drawing an x. My x piece is here, and then I'm going to have 5 unit pieces. 1, 2, 3, 4, 5. Go ahead and get that down on that side of the bar. Now on this side, I'm going to have x plus 3, which is the other part of my problem. So I've used that and I've used that now. I'm good. And I'm going to say x. I'm using 4 bars of my graph paper for x. That's going to be about right. You should be using about the same. And then 3 unit pieces here. All right. Algebra tiles we've looked at before with combining like terms, but from this point forward you're going to need to think of them as kind of like a puzzle. When you have a long side and a long side, you've got to put a piece in there that matches up on both of those sides. So if you remember your algebra tile pieces, we have the x squared, which is a big square, we have the x, which is a rectangle, and then we have our unit pieces, which are these little bitty single pieces. So the only piece that we have that has a long side and a long side is going to be the x squared. So that's how I know what goes in here. And I'm going to go ahead and draw in with my long side and my long side my x squared. Now, down here I see I have a long side and a short side. So I have to put in a piece with a short side and a long side, which could only be that rectangular x. And down here it's the same. The same. And the same. Now over here I have a short side and a long side, and I'm going to put in my x's again. It's just like making a puzzle. All of the pieces have to line up. Now here I have a short side and a short side. So I'm going to put in unit pieces. Short side, more unit pieces. You can see if we were dealing with really big numbers, these problems can get really tedious. Now notice, I'm done drawing my algebra tiles because it's all rounded out. It's not always going to be a perfect square, but it's going to be a rectangle. It's going to be something with equal sides. At least on the top, I'm sorry, those are ones, not x's. These are my unit pieces. Now everything is positive in this problem, so nothing is shaded. So now to get my answer, all I have to do is count up what I've got here. I have 1x squared, so I'm just going to write that by saying x squared. Now notice if I'm just done drawing my algebra tiles, I have not come up with an answer yet. I have to get a final answer. I'm going to count my x's. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to say plus 8x. Now I'm going to count my unit pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Plus 15. Now if you look back at your paper, at what you just wrote down using the distributive property, you should have also had x squared plus 8x plus 15. And that is the final answer.
Again, guys, this is just two different ways of looking at the same problem. We could either do it algebraically using the distributive property, or we can figure it out using the Algebra Tiles method as well.
Go ahead.
So again, just two different ways of looking at the exact same problem. Alright guys, if you look at this, Algebra Tiles is kind of like using a multiplication chart. Like here we have 4 and 5, and if I multiply those together, if I come down on my multiplication chart, I have 20. That's kind of the same deal that we're doing with the Algebra Tiles. It just gives you a little bit of a different way to think about it and connect it with something that you've already seen before, because most of you have seen a multiplication chart. So again, this is kind of working the same way. Filling in the squares of your graph paper is like filling in a multiplication chart.
You don't have to copy any of this down. This. All right.
All right, guys, go ahead and write down number 3. It says parentheses 2x plus 5, parentheses x minus 2.
On your notebook paper.
On your notebook paper, we're going to work this problem using the distributive property first on your notebook paper, and then Ms. Fielden's going to again show you the exact same way to work it, but using Algebra Tiles instead. First of all, I'm going to rewrite this, and instead of the x, I'm going to put a 1 in front. And instead of the minus, I'm going to change that to adding the opposite and say plus negative 2. It'll really help you out here to make sure that you put the 1 in front of the x, and to make sure that you put that as a plus negative 2 so that you look at that 2 as a negative and you don't forget about that sign. So again, with the distributive property, we're going to take this first value of 2x, and we're going to multiply it by everything in the second set of parentheses. So we're going to say 2x times 1x. Then to that, we're going to add 2x times negative 2. Now that we're done with the 2x, we're going to move on to the 5, and we're going to multiply it by everything in the second set of parentheses. So we're going to say plus 5 times 1x, and then we're going to say plus 5 times negative 2. So we're going to multiply each of these out. On this first one, we're going to say 2 times 1 is 2, and then x times x is x squared. And again, we're going to show you that exponent property. You do not have to write that down. That's just letting you know where we came up with the x squared. So again, we multiply the numbers. 2x and 1x is 2x, and x times x is x squared. 2x times negative 2 is negative 4x. 5 times x is 5x, and 5 times negative 2 is negative 10. So we have 2x squared plus negative 4x plus 5x plus negative 10. We're going to put our like terms together, which are those two middle ones if you've done this correctly. We're going to say negative 4x plus 5x, and that's 1x. So we're going to say 2x squared plus either 1x or just x, and then we're going to change the plus negative 10 back to a minus 10. Please make sure that you have all of that written down, with your final answer being 2x squared plus x minus 10.
Okay, so now again we're going to look at this one on your graph paper. So write down the problem again, which is number 3, and in parentheses you have 2x plus 5, and then in your second set of parentheses you have x minus 2. Go ahead and draw your bar. I'm not doing any of this without you, because even for the sake of saving time, I want to make sure that you get all of the steps down and that you're doing it exactly the same way that I'm doing it. So I drew my bar, and then I'm going to look at my first half of my problem, which is going to go on this side. So it's going to be 2x plus 5. And then I'm going to put this x minus 2 up here. So I have two x's here. This one's a little bit different from my last one because I do have two x pieces. So I'm going to mark off my 4 units for my first x, and then I have to put a second x here. I know that when we did Algebra Tiles with combining like terms, there was a little bit of freedom as to where you put certain pieces. There is no freedom with algebra tiles and multiplying binomials. You have to do it exactly like this. 2, 3, 4, 5. So there I have my 2x pieces and my 5 unit pieces. Thank you. And they both should be labeled. Now up here, I'm going to put in my 4 unit pieces for my x. Sorry, I kind of ran out of space there. And notice that because I have to pay attention to detail here, because it is -2, I have to shade in my unit pieces. Because it is -2, I have to shade in my unit pieces. So now I'm going to start multiplying this out. X times x is x squared. If I'm not positive about that, I look and see that I have a long side and a long side. So that could only be x squared. X times x is x squared. Again, like we talked about with the multiplication chart, x times x is x squared. Again, I had a long side and a long side that I had to match up there. Here I have a unit piece and a long side. X times 1 is 1x. X times 1 is 1x. X times 1 is 1x. X times 1, as you may have guessed, is 1x. And lastly, x times 1 is 1x. So now let's look at this side. I have a unit piece times x. 1 times x, and it's -1, is -x. -1 times x is -x. Here I have another long side and another short side. -1 times x, -x. -1 times x, -x. Here I have a short side and a short side. I have -1 times +1. -1 times +1 is -1. -1 times +1 is -1. -1 times +1, -1. -1, -1, -1. And then over here as well. Again, you can see how it can get really tedious drawing these when you have really big numbers. Hopefully you're doing a better job of shading than I am because I'm using pen because it shows up better on the camera, but you should be using pencil. And you'll also probably notice here that when I started with a negative up here, when I started with negative unit pieces up here, everything in this column ended up being shaded. Because of the rule of multiplication, it's true that when I multiply negative times a positive, the result is going to be negative. So because this is negative and this is positive, my product is going to be a negative number. So now I'm going to look and see if I have 0 pairs, because I actually do this time. Because I have negatives and positives. I have 4 negative x's. And I also have 4 positive x's over here. I have a total of 5, but I can go ahead and cross out these 4. I can go ahead and cross out these 4 because they do cancel out. And I'm left with 1 positive x. I have 2 positive x squareds. Those stay because there are no 0 pairs. So I'm going to write that as 2x squared. And then I'm going to say plus x because I have 1 positive x. And then I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 negative unit pieces. So I write that as saying minus 10. So that should be your final answer there, 2x squared plus x minus 10. And you should have all of that down on your paper before you move forward.
All right, number 4, go ahead and write this down. It says parentheses n minus 3 and then parentheses n minus 6. And again, we're going to do just like we did the rest of them. We're going to use the distributive property first and then the algebra tiles. But first, we want you to take a minute and try this on your own using both methods. So go ahead and pause the video now and try this one. Use the distributive property to try it, and then try to use it using the algebra tiles. And when you're finished, go ahead and hit play, and we will look to see if you got it correct. All right, hopefully you've paused the video and taken a minute to see if you can get this one on your own. So to use the distributive property, we're going to change -3 to +-3 and -6 to +-6. I promise that this will help you get your signs correct. So please make sure that you do adding the opposite here. So we're going to take this first n and multiply it by both things in the second set of parentheses. So we're going to say n times n, and please make sure you're drawing your arrows as well. Again, it will keep you from making simple mistakes. Then we're going to say plus n times -6. And when we're done with the n, we're going to move on to this -3. And we're going to multiply it by everything in this second set of parentheses. We're going to say -3 times n, so plus -3 times n. And then we're going to say plus -3 times -6. We're going to multiply these together and say n squared plus -6n plus -3n plus 18, because we went ahead and did all of our multiplication. Then we're going to put our like terms together. We have -6n plus -3n, and that gives us -9. So our final answer here is n squared minus 9n plus 18. Please make sure that you have all that written down. If you got it correct, good job. If you did not, please erase what you did wrong and write down the correct way to work the problem.
So, all right. Now we're going to look at this in Algebra Tiles, and I want you to do this one on your graph paper in Algebra Tiles, but I'm going to go ahead and show it to you on the PowerPoint because there's a lot of shading, and when I'm shading in pen, it gets real confusing. So go ahead and set up that bar like I've already shown you to set up. You don't need to write all of this stuff over here because you've already written it down on your notebook paper. So you're on your graph paper now. And don't get confused by the fact that we're using a variable of n. We're still going to draw that as an x, just like we have been. That's just your way of showing your variable. All right, so on this side we have n plus a -3, and on this side we're going to have n plus a -6. So again, you can see that we've added the opposite is all we've done there. Don't let that confuse you. And you should have done the same. So we've gone ahead and put in an x piece here to show our n, and then -3 unit pieces here to show our -3.
And if you used 4 spaces for your x instead of 3 like they've done here, don't think that that's wrong. That's fine.
Yeah. All right, and then you've got your x piece here to show this n, and then you should have -6 units here. Go ahead and try to work this one out on your own, obviously using pencil, but go ahead and try to work this one out on your own and see if you can get the right answer on this one now that we've set it up for you. All right, hopefully you paused the video and attempted to work this one on your own. Now let's go over and see what you got. X times x is going to give us x squared. We have a long side and a long side if we're not entirely sure about that. Now we have our -1 times x, 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 which gives us 6 negative x pieces. And then let's look down here at our -1 times this x. It's going to give us 3 negative x pieces. And over here, we're going to have -1 times -1. Now, the rule with multiplication tells us that when we're multiplying two negatives, it gives us a positive. So don't confuse this here. Make sure that these unit pieces are positive. And if you've worked this out on your own, make sure that you got +1, because -1 times -1 is +1. So when my negatives meet, it becomes positive. So now all I have to do is count up what I have here to get my final answer. Because I don't have any zero pairs, nothing cancels out. I have 1x squared, which I'm going to write as x squared, or n squared in this case. Then I have 1, 2, 3, 4, 5, 6, 7, 8, 9 negative x's. So I'm going to write that as -9x. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 positive unit pieces, and I'm going to write that as +18. So n squared minus 9n plus 18 should be your final answer for this on your graph paper with your algebra tiles. Make sure that you have that down before you move on.
Alright, so we now should be able to multiply binomials algebraically and using manipulatives. It says 6 examples, and there are 6. We did 4 of them in this video. We're going to finish up the other 2 in class tomorrow because we actually want you to get your hands on the algebra tiles and move them around and that kind of thing. So we're going to do those in class, the last 2 of them. So this is the end of your video. Thank you for watching.